Okay, this is a video demonstrating quicksort. In quicksort, what we do is we choose one of the elements of our list around which we partition the other elements into elements that are both less than, equal to, and greater than the element that we choose. So let's start by choosing the first element in our list, the 5. Choose the 5 to be the partition element. So I'm going to put the 5 here in the middle. I'm then going to divide the elements into elements that are greater than and less than the element 5. So 14 and 13 are greater than 5, so I'm going to put them on the right hand side. 22 is greater than 5, I'm going to put it on the right hand side. 2 I'm going to put on the left, the 4 I'm going to put on the left, the 0 I'm going to put on the left because it's less than 5. 54 is going to go on the right. 7 is going to go on the right, and I'm going to run out of room, so I'm going to move my 5 over here, and I'm going to put my 12 here on the right. Doesn't matter which order I put these in. The idea, though, is that I have elements on this side of the screen to the left that are less than the element that I chose, the pivot element or the partition element, and items that are greater than on the right. Now I'm going to use the same algorithm to quicksort the left items, and then I'm going to use the same algorithm to quicksort the right elements. So I'm going to start with the left, and I'm going to choose the first element in my list, and I'm going to partition these values into items that are greater than the 2 and items that are less than the 2. And I'm going to have 3 partitions, those that are less than my partition value, those that are the same as my partition value, those that are greater than my partition value. And then I'm going to do the same thing. I'm going to sort on the right, and I only have one element, so I reach what's called my base case in my quicksort algorithm. And my base case says that if I have only one element, then I know that that list is sorted, so I can stop there. So I know that this list consisting of just the 0 is in sorted order, so I can put it back where it was. Then I'm going to go to the left of my partition value, and I'm going to sort the values on the left of my partition value. There happens to be only one item on the left of my partition value, and that would be the base case. I know that my 4 is in the correct order, so I can put it back where it was. And I've now sorted to the left, sorted to the right, and you'll notice that I have a sorted list of those elements that were on the left of my initial partition value. So if I move those back up to where they were, I now have those that are less than my partition value in sorted order. I can now add my partition value to that list because it comes next in the order, and I can move over to the values on my right hand side and use the quicksort algorithm to sort these items in the same manner. So I'm going to choose my middle element, or sorry, my first element as my partition value, and partition the values into those that are greater than this element, which is the 12, and those that are less than this element. So it happens that I have 4 values that are greater than the 12 and 1 value, come on, move with me, that is less than the 12. So I now sort, using quicksort algorithm, the values that are on the left hand side. I happen to have only one value on that left hand side, so I know it's in sorted order. That's my base case. I move it back where it belongs, and I can add my partition value to that, forming a sorted list 7 and 12 before I move over to the items that are on my right hand side, which I'm going to use my quicksort algorithm to sort again. So I'm going to choose my first element, and I'm going to divide these elements into values that are less than my partition value and items that are greater than my partition value, which are the 22 and 54. And once again, I'm going to use quicksort to sort the values on the left. There happens to be only one value on the left, so it's in sorted order. I can add my partition value to that element, and then I'm going to quicksort the values that are greater than my partition element. So again, I choose the first element, and I divide the rest of the elements into those that are less than, those that are greater than this element. I happen to have nothing that's less than the element, so I can now add my partition value to the sorted list that I had before, and I sort what's on the on the right hand side. Happens to be only one value on that right hand side, so I can add that to what I to the sorted list that I've started formulating here. I've now sorted the values on the right hand side of this initial partition value 12, so I can move these back up and join them with this list of already sorted elements. And this forms a sorted list of all the values that are greater than my initial partition value, which was 5. So I can add this list, this sorted list now, to my partition value 5 and the sorted values that were to the left of it. And magically, if I've done this correctly, we end up with a sorted list having been sorted using the quicksort algorithm. So what's the complexity of quicksort? Quicksort runs in order n log n time in the best and average cases. So we have log n levels if we're dividing things, if we're dividing elements, we have log n levels that we divide them into, and we look at each level, we look at n items at each level. So quicksort runs in order n log n time. However, quicksort can deteriorate very quickly to an order n squared complexity if the partition value is chosen poorly. For instance, if we choose the largest or smallest element each time, all of the elements go on to one side or the other, and we end up with n levels that we need to evaluate. So we have n levels times looking at n elements at each level, we end up with an order n squared time complexity for quicksort.